Children, let us take up the next numerical. An aqueous solution of glucose is made by dissolving 10 grams of glucose C6H12O6 in 90 grams of water at 303 Kelvin. If the vapor pressure of pure water at 303 Kelvin is 32.2 mm mercury, what would be the vapor pressure of the solution? Very simple numerical, children. You need to read the numericals 2 times, then you list down whatever the data given in this numerical. Let me solve this. Look at here. 10 grams of glucose is dissolved in 90 grams of water. That means WB is equal to 10 grams. Weight of the solute. Solute is what? Glucose. Then weight of the solvent is given is water. How much? That is 90 grams. Then we need to find out the molar mass of glucose because the formula is given here. Mb is equal to 180 unified mass. You can calculate how? By adding atomic mass of all the atoms of the element present in this molecule gives you 180 unified mass. Then Ma is what? Molar mass of water. That is equal to 18U. Now what else is given here? Look at here. 32.2 mm of mercury is what? It is vapor pressure of the pure solvent. That is Pa naught. Is it not? It is how much? 32.2 mm mercury. What are they asking? They are asking to find out vapor pressure of the solution. Children, understand that a non-volatile solute is dissolved in a volatile solvent. That means, according to Rolle's law, you can write Pa is equal to Pa naught into Ga. Remember, according to Rolle's law, for a solution containing a non-volatile solute in a volatile solvent, Pa is equal to Pa naught into Ga. Pa naught, you know that is 32.2 mm mercury, and we need to calculate what? Ga. Hope you are getting that. You understand or not? Look at here. Ga is equal to Na upon Na plus Nb. Now Na we need to calculate, Nb need to calculate. Is it not? Look at here. Let me go ahead. Na, number of moles of solvent. That is equal to Wa upon Me. That is given mass upon molar mass. What is the given mass here? 90 grams. And molar mass of water is how much? 18. 18 5s are. Na is equal to 5. Is it not? Now similarly, you can go for Nb. Nb is equal to Wb upon Mb. Wb is how much here? Wb is equal to 10 grams upon 180. Children, if we simplify that, we are going to get 0.556. Now I got Na and Nb. Now we'll go into find out Ga. Look at here. Na is 5 upon 5 plus 0.556. It is equal to 5 upon 5.556. Children, if we simplify that, I'm going to get 0.989. This is what? Ga. Hope you're getting that. Is it not? Now, once you got the Ga, you know Pa naught, then substitute the value here. Look at here. Ps is equal to Pa naught. How much? That is 32.2 into 0.989. Hope you're getting that. Now, if I simplify that, we're going to get 32.44 mm of mercury. So let me go for the next numerical. A solution containing 12.5 grams of non-electrolyte substance in 175 grams of water gave a boiling point in elevation of 0.70 Kelvin. Calculate the molar mass of solute. Kb value is given here, 0.52 Kelvin kg per mole. Children, they have given one clue here. What is that? Non-electrolyte substance. That means it is not a electrolyte. If it is not electrolyte, it will not undergo dissociation in the solution. That means the Van 't Hoff factor does not play any role in this numerical. Keep it in your mind. Okay. Read the numerical 2 times and then list down whatever the data is given here. Let me list down. Look at here, a solution containing 12.5 grams of solute. That means WB is equal to 12.5 grams. And WA is equal to what? 175 grams. BP in elevation in boiling point. That means delta TB is given, children. That is equal to 0.70 Kelvin. And what are they asking? They are asking MB of solute. And they are given here KB is equal to 0.52 Kelvin kg per mole. Children, you know the mathematical expression for elevation in boiling point, is it not? What is that? Look at here. Delta TB is equal to KB into WB into 1000 upon MB into WA. Is it not? Now, what you are supposed to find out? You are supposed to find out the molar mass. I'll reshuffle the expression. MB is equal to KB into WB into 1000 upon, okay, delta TB into WA. Now substitute the value. KB value, you know that 0.52. WB is how much here? WB is equal to 12.5 into 1000 upon delta TB. How much? That you did not write, right? Written, yeah, okay. 0.70 into WA is how much here? WA is equal to 175 grams. Children, if you simplify this, you are going to get 53.06 gram per mole, or you write U, unified mass. So this is what MB. Simple numerical, but you need to understand the numerical and then you need to solve the numerical. Hope you understand that. Let me go for the next numerical. Sixth numerical. A solution containing 8 grams of substance in 100 grams of diethyl ether boils at 36.86 degrees Celsius, whereas pure ether boils at 35.60 degrees Celsius. Determine the molar mass of the solute. Kb of ether is given, that is equal to 2.02 Kelvin kg per mole. As usual, you read the numerical for 2 times and then list down whatever the data is given. This is also very simple numerical where you are supposed to find out MB of the solute, right? So let me solve this solution. So WB is given, that is equal to 8 grams. WA is given, how much? 100 grams diethyl ether. See, when 10 grams of substance is dissolved in 100 grams of diethyl ether, it boils at 36.86 degree Celsius. That means solution's boiling point. Hope you are getting that. That is TB is equal to 36.86 degrees Celsius. Whereas pure ether solvent boils at 35.60 degrees Celsius. That means, yeah, you're right. That is TB naught. That is equal to 35.60 degrees Celsius. And what else is given? KB is given 2.02 Kelvin kg per mole. Is it not? Now what are you about to find out? You are supposed to find out molar mass of the solute. Remember, for finding out molar mass, you need to know delta TB also, is it not? Look at here. Delta TB, expression you know that, elevation in boiling point is equal to TB minus TB naught. What is TB value here? TB is how much? 36.86 minus 35.60. 35.60. Children, if you subtract here, you are going to get 1.26 degree Celsius. So this is what delta TB. Once you find out delta TB, now it's easy for finding out MB. Expression on that, delta TB is equal to KB into WB into 1000 upon MB into WA. Reshuffle the equation. MB is equal to KB into WB into 1000 upon delta TB into WA. Now substitute the values. KB is how much here? 2.02 into WB is how much here? WB is 8 grams into 1000 upon delta TB you calculated here. How much? It is 1.26 into WA. WA is 100. Children, if you simplify this, you are going to get 128.3 unified mass, otherwise gram per mole. So this is what MB. Let me go for the next numerical. Find the boiling point of solution containing 0.520 grams of glucose, that is C6H12O6, dissolved in 80.2 grams of water. Given Kb of water is equal to 0.52 Kelvin kg per mole. Very simple numerical again. Children, understand the numerical. Then only it is possible for you to solve the numerical. Let me solve this problem. Solution. Given data. Look at here. 0.520 gram of glucose, that is WB is given, WB is equal to 0.520 grams. Dissolved in 80.2 grams of water. Water is what? Solvent. So I'll go for WA is equal to 80.2 grams. And what is they given here? Look at here, Kb of water is given. Kb of water is equal to 0.52 Kelvin kg per mole. And you also know that TB naught, as they given here, water is a solvent. You know, boiling point of water, that is how much? It is 100 degrees Celsius, or you can write 373 Kelvin. Anyone is sufficient for me. Next, look at here. What are they asking? They are asking to find out TB, that is boiling point of solution, that you need to find out. Remember, to find out this, you should know delta TB, that you need to find out by using the data. Not only that, in the expression of delta TB, there is MB. That means you need to calculate the MB. What is MB? Molar mass of solute. What is solute here? Glucose. The formula is given here. By using the formula, you can calculate the molar mass. How do you find out that? You add atomic mass of all the atoms of different element present in that molecule. You are going to get the molar mass. Look at here. That is equal to 180 unified mass, otherwise called gram per mole. Now, let me go for the expression. Delta TB is equal to Kb into WB into 1000 upon MB into WA. Now I will substitute the value. Kb is how much here? 0.52. WB is how much here? 0.520 into 1000 upon MB is how much here? 180 into WA is how much here? W is 80.2. Children, if you simplify that, you are going to get 0.0187 is the delta TB. What is delta TB? Elevation in boiling point. Children, you got delta TB value and you know TB naught, that is boiling point of pure water or the solvent. In this case, look at here, it is the 100 degrees Celsius or 373. Now you know the expression delta TB is equal to TB minus TB naught. Is it not? Now TB is equal to, what do? Delta TB plus TB naught. Now delta TB is how much here? 0.0187. What is TB naught here? 373 Kelvin. You can write 100 degrees Celsius also, whatever. Okay, I'll write 373 Kelvin. Now you are going to get 373.0187 Kelvin. This is what boiling point of solution. Let me go for the next numerical. A solution containing 18 grams of non-volatile solute in 200 grams of water freezes at 272.07 Kelvin. Calculate the molar mass of the solute given Kf of water is equal to 1.86 Kelvin kg per mole. Children, again is a new simple numerical. Let me solve this numerical for you. Solution. Given data. Now 18 grams of non-volatile solute, that is Wb is equal to 18 grams, is dissolved in how much? 200 grams of water, that is Wa is equal to 200 grams. Is it not? And what is they given here? Solution freezes at 272 Kelvin, that means Tf is equal to 272.07 Kelvin. Is it not? Children, one clue is given. What is that? Solvent is water here, and you know the freezing point of water, that will be Tf naught, that is equal to 273 Kelvin. Remember, as the given freezing point of solution in Kelvin are taken in Kelvin. Imagine if they would have given in the degree Celsius, we should have taken in the degree Celsius only. Hope you are getting that, right? Now, what is the given here? Kf is equal to 1.86 Kelvin kg per mole. And MB you can calculate. Okay. Now, for calculating MB of the solute, you should know what is delta TF. What is delta TF? Depression in freezing point, and you know the expression for that. Delta TF is equal to TF naught minus TF. And what is TF naught? That is freezing point of pure solvent, in this case water, it is 273 Kelvin. 273 minus solution's freezing point, how much here? 272.07 Kelvin. Children, if you go for subtraction, the answer is 0.93 Kelvin. This is what? Delta TF. Hope you are getting that. Once you got this delta TF, now it is easy for you to calculation of MB, nothing but molar mass of the given solute. Now delta TF is equal to Kf into Wb into 1000 upon MB into Wa. A reshuffle, look at here. MB is equal to Kf Wb into 1000 upon delta TF into Wa. I'll substitute the value here. Look at here. MB is equal to Kf is how much here? 1.86 into Wb is how much here? Wb is equal to 18 grams. Is it not? 18 grams into 1000. Delta TF is how much here? It is 0.93 into 200 grams of water. Simple, children. If you simplify that, hope you can do that. MB you are going to get is 180 unified mass or gram per mole. This is how you need to calculate molar mass of non-volatile solute which is dissolved in solvent. Let me read out the next numerical for you. Calculate the temperature at which a solution containing 54 grams of glucose C6H12O6 into 50 grams of water will freeze. Kf of water is given, that is 1.86 Kelvin kg per mole. Children, what are they asking here? They're asking you to find out the freezing point of the solution. Let me solve this numerical for you. Solution. Given data. WB is how much here? WB is equal to 54 grams. WA is how much here? WA is 250 grams. And MB, you need to find out for glucose, it is 180 unified mass. How do you get this? You add atomic masses of all the atoms of a different element present in that molecule. Then you are going to get molar mass of that particular solute. Now, TF naught. What is TF naught? Freezing point of a solvent. What is solvent here? The solvent is water. That means you know this. How much? It is 273 Kelvin. Hope I getting that. What is they given here? Kf is given. How much? 1.86 Kelvin kg per mole. Now what are they asking? They are asking to find out Tf. Children, to find out Tf, you should know delta Tf, or that depression freezing point. Now you know the expression for delta Tf is equal to Kf into WB into 1000 upon MB into WA. Now I'll substitute the value. Kf is equal to 1.86, WB is equal to 54 grams into 1000 upon MB is equal to 180, and WA is equal to how much? It is 250 grams. Now children, if you simplify that, you are going to get 2.232 Kelvin. This is delta Tf. Now once you get delta Tf, it is easy for me to go for finding freezing point of solution with the expression delta Tf is equal to Tf naught minus Tf. Is it not? Now Tf is equal to Tf naught minus delta Tf. What is Tf naught here, children? Tf naught is how much? It is 273 Kelvin. Freezing point of water. And delta Tf is how much here? 2.232 Kelvin. If you subtract this, you are going to get, children, 270.9 Kelvin. This is what is that? Tf. What is Tf here? Freezing point of solution. Children, let us take up the next numerical. 15 grams of an unknown molecular substance was dissolved in 450 grams of water. The resulting solution freezes at minus 0.34 degrees Celsius. What is the molar mass of the substance given? Kf of water is equal to 1.86 Kelvin kg per mole. Very simple numerical, children. Let me solve. Solution. Given data. So WB is given how much? 15 grams. WA is given how much? 450 grams. Freezing point of solution is given. That means Tf is given how much? Minus 0.34 degrees Celsius. One hint is given. What is that? Solvent is water. That means freezing point of water is, you know that Tf naught is equal to 0 degrees Celsius. As this Tf, otherwise called freezing point of solution, is given in terms of a degree Celsius, I should put, you know, freezing point of pure water also in terms of a degree Celsius. Next, Kf is given how much? It is 1.86 Kelvin kg per mole. Is it not? Now what are they asking? They are asking to find out molar mass. Children, to get a molar mass, you should know what is a delta Tf also. And what do? First, I'll find out delta Tf and then I go for finding out the molar mass. Now, you know the expression delta Tf is equal to Tf naught minus Tf. What Tf naught here? 0. Is it not? Minus. Look at here. What is Tf? Minus 0.34. That means is plus 0.34 degrees Celsius. This will be delta Tf. Once you get delta Tf, let me go for finding molar mass. Delta TF is equal to Kf into Wb into 1000 upon Mb into Wa. Is it not? Children, substitute the value here. Now what are you supposed to find out? Mb. So I reshuffle the expression here. Kf into Wb into 1000 upon delta TF into Wa. Kf is how much? 1.86. Wb is how much here? Wb is equal to 15 grams into 1000 upon delta TF is how much here? 0.34 and Wa is how much here? It is 450 grams. 450 grams. Children, if you simplify this, you are going to get 182.35 gram per mole or unified mass. This is Mb. Children, let me give one homework for you. The boiling point of benzene is 353.23 Kelvin. When 1.80 gram of a non-volatile solute was dissolved in 90 grams of benzene, the boiling point of solution is raised to 354.11 Kelvin. Calculate the molar mass of the solute. Given Kf of benzene is equal to 2.53 Kelvin kg per mole. Easy numerical. Hope you will solve this and tell me the answer tomorrow in the class. Let me go for the next numerical. A solution of a glycerol with the molecular formula C3H8O3 in water was prepared by dissolving some glycerol in 500 grams of water. This solution has a boiling point of 100.42 degrees Celsius while pure water boils at 100 degrees Celsius. What mass of glycerol was dissolved to make the solution? Given Kb of water is equal to 0.512 Kelvin kg per mole. Again, children, read the numerical for 2 times and list down whatever the data given. Okay, solution, given data. Wa is given how much? 500 gram, is it not? And Bp of solution is given, that means Tb is given, that is 100.42 degrees Celsius, and Tb naught of water, that is 100 degrees Celsius is given. What is Kb is given? 0.512 Kelvin kg per mole, is it not? Now Tb is given, Tb naught is given. Now it is easy for you to find out the delta Tb. Children, delta Tb expression, you know that is Tb minus Tb naught. Now Tb is how much here? Tb is equal to 100.42 minus Tb naught is equal to 100. That means delta Tb is equal to 0.42 degree Celsius. Now apart from that, now you should know Mb also, is it not? What is that? Molar mass of glycerol. They given the formula C3H8O3. Now how many atoms of carbon are there? Look at here, 3, and the atomic mass of carbon is 12 plus how many atoms of hydrogen? 8. The atomic mass of hydrogen is 1 plus how many atoms of oxygen are there? 3. Atomic mass of oxygen is 16. Children, if you simplify this, you are going to get 92 unified mass or gram per mole. That means you know Wa, Mb, Tb, Tb naught, Kb, delta Tb naught. What are they asking? They are asking to find out Wb. Is it not? Now you know the expression. What is that? Delta Tb is equal to Kb into Wb into 1000 upon Mb into Wa. Is it not? Now I'll reshuffle. Look at here. WB is equal to delta TB into MB into WA upon, we have what is that, KB into 1000. Now substitute the value. Delta TB is how much here? Delta TB is equal to 0.42 and MB is equal to 92 and WA is how much here? WA is equal to 500 upon KB they are given here. How much? 0.512 into 1000. Children, if you simplify, you are going to get 37.23 grams of glycerol. Let me read out the next numerical for you. Addition of 0.643 gram of a compound to 50 ml of benzene with a density 0.879 gram per ml lowers the freezing point from 5.51 degrees Celsius to 5.03 degrees Celsius. If the Kf for benzene is 5.12 Kelvin kg per mole, calculate the molar mass of the compound. You should be very careful while taking the WA value because they are given the density. You cannot take 50 ml directly. You should convert, then only you have to take it. Let me solve. Solution. Given data. WB is given how much? It is equal to 0.643 grams. Now WA. Now you know this, density is equal to mass by volume, is it not? Now I need mass, so mass is equal to density into volume. Now density is how much here? 0.879. The volume is equal to 50 ml. Children, if you solve this, you are going to get 43.95 ml. So this I'll take it here for WA, that is 43.95. Next, what else is given here? 5.51 is what? It is TF naught is equal to 5.51 degrees Celsius. TF, what is that? Freezing point of solution. It has decreased here, 5.03 degrees Celsius. Now, Kf is given how much? It is 5.12 Kelvin kg per mole. What are they asking? They are asking molar mass of the compound. Now, for finding the molar mass, you should find out delta TF also, is it not? You know that delta TF is equal to, you know the expression, what is the expression here? TF naught minus TF, is it not? What is TF naught here? TF naught in this case 5.51 minus TF is how much here? 5.03. Now if you calculate this, you are going to get 0.48 degrees Celsius. This is what delta TF. Once you get delta TF, now you can go for finding the molar mass of this compound. So delta TF is equal to Kf into WB into 1000 upon MB into WA. Now MB you are supposed to find out. Kf into WB into 1000 upon how much? Delta TF into WA. Now Kf is how much here? 5.12. WB is how much here? 0.643 into 1000 upon delta TF is equal to 0.48. WA is equal to 43.95. Now if you simplify this, you are going to get 156.7 gram per mole, otherwise unified mass. This is what MB.